So today we'll see of content of index, simple prefix B+Tree and maintenance. In content of index, we mainly see that index, as we have already seen, index is a concept which is used for in B-trees for improving the efficiency of saving my index inside memory if I'm having an index of large size. Okay, so here we are going to see another index technique which can be used. Okay, here indexes is not usually we have studied that it is a roadmap for searching a record, and similarly we can tell here in the index of what we're going to see, the technique which we see, we are using separators. We're not using keys, instead we're using separators. Now what are these separators do? They are used for distinguishing between two blocks or the two contents or the contents of the two blocks. Now the contents of the blocks is nothing but the records. Okay, so here now what are the properties of a separator? The separator can be of variable length. Using fixed length always have demerit of wastage of space. So here we are using variable length separator, and we maximum try to use the shortest separator so that the space usage is very less. Here the main rule which we have to keep in our mind is every search key which is less than the separator will always go to the left block, and the key which is equal to the separator will go for the right block, and the key which is greater than the separator will go for the right block. So we'll see with an example. So these are the set of blocks which is saved inside my file, where each block contains a set of records. So this is my first record, and which mainly contains records from Adam to Bernie, and here the next one is Bolin to Cage, Cam to Dutton, etc. Okay, and here we are seeing separators. Now here the separator between block 1 and block 2 is BO. Okay, now this is what the separator which we have seen here before. The separator will be the minimum must be a separator which is having minimum number of letters, and it is a variable length. Okay, so BO is the separator used here. Now when we consider how is the separator been identified, it is a process, or we have an algorithm which is used for identifying the separator with the smallest size. Okay, for every block let it be 3 and 4. Okay, 3 and 4, that is Cam, Dutton and Embry. Here we have a list of keys, separators which is given. From this we select which is the efficient separator for separating both the block 3 and block 4. Okay, so we are going for an algorithm to see that how is this separator been identified. Here the very smallest separator is E, so you can see that E is been selected. Similarly we see with an example and the algorithm. So this is the algorithm which is used for explaining how the separator has been identified. Here we are having a key called key 1 and key 2, and then we have a sep. Okay, so we have it as we it is written in the algorithm, we have to put these keys, okay, the separator list inside an array, and both the key 1, key 2 and the separator will be pointing to the starting location of my array, that is 0. And now we start with the processing. So separator is equal to key 2, so separator will be now pointing to the location 0, and key 2 will be now pointing to BK. Okay, so then we go for incrementing sep, that is equal to 1. Okay, now it is 1. Now we go for the checking thing. If key 2 is not equal to key 1, actually key 2 is equal to key 1. Okay, that is BK. So we come inside. Now is key 2 equal to 0? No, key 2 is not equal to 0, it is BK. So what we have to do means we go down, we increment key 2 and key 1. Okay, so now we goes for incrementing 1 and 1. Okay, so now we go up and we assign sep is equal to key 2. That is why we have star sep is equal to bn, and then we increment sep it equal to 2. So now the sep becomes 1. Okay, now again we go for the processing. The same thing keeps continuing, and to the last we continue that BO becomes a sep, and this has been returned. Okay, so this is how the separator is being identified in the case of B0 and block 1 and block 2. Next is a simple prefix B+Tree. In the case of a simple prefix B+Tree, we need to see how is a simple prefix B+Tree implemented. So we have seen the index and the separators used for the index. Now we'll see how has it been implemented in simple prefix B+Tree. So what is this index set? Index set is nothing but the index which is identified from the separator, and it is introduced with the sequence set of blocks. Okay, for the sequence set of blocks which is containing the records. So this is known as our index set. Now the combination of both this sequence set and the index set which we have come across is known as simple prefix B+Trees. Now why is it called as simple prefix? Simple prefix in the sense we always, as we have already explained, simple prefix in the sense simple, the prefix, the separators will always be the prefix. It is not taking the whole separator, or it is taking only the prefix of the key. So it is known as the shortest separator is being chosen as our separator. So that is why it is known as simple prefix. Here this is an example of showing how the simple prefix B+ key has been designed. As we have already seen in our example, this is an example which explains the B1, B2, B2, B3 and all of a file. Now we need to represent it as a B+Tree. How is it represented? The same case, the sequence set remains the same. So here we see that the sequence remains the same, and then we go for the index set. So this is how the index set comes. The index set is nothing but the separators which we have designed above. So here it is BO and CAM. So here in the sense of B1 and B2, the index set is BO and CAM. Okay, so that becomes our index for 3 blocks: B1, B1, B2 and B3. Okay, and then we go for E. E becomes the middle separator, so it becomes our root. Okay, and then we go for F and Fox, which becomes our another index set for blocks 4, 5 and 6. Okay, so this is how the B+Tree has been assigned. Next we go for the maintenance. In the maintenance we mainly see whenever an insertion or a deletion